So we're looking at page 52 in the Unit 3 packet. We're learning about percentiles using the standard normal curve. Before we get started on that, I wanted to remind you that in the calculators tab of Blackboard, you can access the different calculators that I've posted up over time related to the content in the respective units. All right, so the ones that would be appropriate in this case, or the one, would be in the Unit 3, specifically normal PDF. So if you tap on that one, it brings you to a Desmos link, which I tried to make as user-friendly as possible. It's kind of a little on the busy side, so I apologize for that. And you'll see that there are some overlapping graphs that we'll have to account for, but it gets the job done, and it's there for you as you need it. All right. So, but you could also use the normal dist function that I showed in the last video. This one is just all done for you, so I figured you'd have that option. All right. So we will have to actually go the other way though and determine z-scores given particular probabilities. So that's a new little twist. All right. So in the first example here, it says find the z-score that represents the 90th percentile. Now, since I have no idea what the final answer is going to be, I'm just going to ballpark where 90% feels like it ought to be. All right, that kind of feels like 90% of the graph. All right, so about 0.9. And so there's two ways to handle this. One is a little bit more complicated than the other. All right. My little bracket here looks kind of weird, so I was trying to get a little too cute with that. Let me just dial down the pizzazz a little bit here. All right, so what we're looking for is the z-score corresponding with a 0.9 to the left. All right, and it's going to be some sort of approximate value. Now, what we're going to type in, you could see the whole shibiggity bang here. There's a lot of stuff to type in, but if you were to do it manually, you'd go to functions, distribution, and then you would type in inverse CDF. I mean, you're not really obviously typing in inverse CDF, you're just tapping on it. It opens up a set of parentheses. You got to tell it what function, what distribution you're working with. We're working with a normal distribution. All right. Now this is a standard normal distribution. So 0, 1. All right. So I'm going to tap on that. I'm going to type in the 0, 1. I'm going to close that up. And then I'm going to put in a comma and the area to the left. All right. So this is the area to the left of the z-score. Now that's a z-score that we don't know, but we do know the area to the left of that unknown z-score is 0.9. All right, so I could put in a 0.9. All right, so that's what I'll do, comma 0.9, and you get about 1.282. Now again, I had no idea where it was going to be, but what I do know is that it was going to be to the right of the center, because the center's at 0, values to the left of the center are negative, values to the right are positive. So at the very least, I know that I'm in the right neighborhood. All right. So there's that approach that you can use, and some people are just fine with that, because honestly, the way Blackboard is structured, some folks are kind of more keen on giving that a wide berth and saying, you know what, I'm not really too interested in navigating Blackboard. I'd rather do it all on my own, and that's perfectly fine. All right. So if that's the case, then you're probably okay with this approach. All right. And with that in mind, you could even do the next problem where it says Q3, as long as you know that that's the 75th percentile. Oops, that's poor quality eye. Let me get rid of that. That's a z-score having 75% of the area to its left. I'm still getting a little funky with my my arrows here. That was looking pretty bad. So 75. So the z-score corresponding with that 75, it's going to be the same computation that we just did, just with a 0.75 instead of a 0.9. The one thing that I got to impress upon people is you can save your Desmos. So if you're following along right now and you're saying, well, I don't like Blackboard, I don't want to have to do this every time, I don't have to write this in every time, then don't. Save it and call it percentiles for normal distributions. Give it a title. Save it to your account so you have it. All right, so here all I have to do is type in a 0.75. And so we're looking at about 0.674. It's less area, all right? Less area would mean that it's not going to accumulate as much distance going to the right, so that seems to make sense. All right, so I think we're pretty good shape there, but let me show you how my calculator works. I'm going to get rid of that so it's not distracting. Let me get rid of that. So finding area under the normal curve given a z-score. Well, that's not what these questions are asking for. Finding z-score given area under the normal curve. Et voila. All right. So it's just my keyboard keeps coming up every time I tap that. All right. The following will give a z-score with area p to the left of that z-score. Well, I had it as a default of 0.75, so there we go. I have the function built in, right? Inverse CDF. I mean, you could tap on it and scroll, but I think you'll believe me that it's set up the right way because this number is what we just got. All right, so I can just slide this over to 0.9, which was the previous problem, and you see we get 1.282. So it's pretty good. Now we have and you can see that this corresponds with the purple shading. All right, so the more I go to the right, the more purple shading I have. The more I go to the left, the less purple shading I have. So whatever our percentile value is, 0.5, for example, right smack dab in the middle, gives you a z-score of 0. All right, so we now have a calculator that's pretty much set up to give us percentile z-scores. All right, so that's pretty nice. If you weren't interested in using this applet beforehand, maybe I just changed your mind. We'll see. All right, so what I recommend is if you're using this this calculator for a test, just retitle it. Title it with the question number. You know, this is question 4 on the Unit 3 test, whatever it is. Just so you don't change the original one, because you could save it to your own archives. Save your original one. If you don't want to go back and forth to Blackboard, you just save it to your own account. And then retitle it every time you make a change. All right. So now the next set of problems are going to be a whole lot easier because we have this applet. But yeah, normal distributions are specific to a given mean and standard deviation. Very often they pertain to real life situations. So I mean, these are as real life as they're going to get. I mean, at least without getting into real data collection for this class. Anyway, the distribution of weights of black bears is assumed to be normally distributed. Okay, so that's a greasy typo there for somebody. The distribution of weights of black bears is assumed to be normally distributed with a mean of 183 pounds and a standard deviation of 121.8. Find the probability that a black bear selected at random will have a weight between 150 and 180 pounds. All right. So there's two ways to handle this. One would be to compute the z-score for each one of these values. All right. The other way would be to use a normal curve calculation with the mean and standard deviation of 183 and 121.8. I'm going to show you both ways, right? Because sometimes questions ask you to do different things. All right. So what we're going to do is we're going to find the z-scores for 150. And we're going to do the z-score for 180. All right, so 150 minus the mean, 183, over the standard deviation of 121.8. And then we're going to do the same thing, but this time with the 180. And again, like I said, there's two ways to do this. I'm showing you the longer way first because honestly, sometimes the question asks you for a z-score also. All right, but you can see here, if we go into the first little drop down, z min, z max, this calculator, the way I have it set up, it's calling for these values anyway. All right. So what I can do, and so I'll show you two ways to handle it. One way is a little slicker than the other. All right. So we can do 150. Everything comes in twos. It's like, oh, I can show you two ways to do things. So we're looking at about negative 0.271. And then I could just make that 150 into a 180. About negative 0.0246. All right, so those are my two z-scores. Both of them are pretty close to center. So one just a smidge off. I'll make that a little thinner. And the other... So we're talking about this little sliver here. Oop. That jumped on me. That was not on purpose. So about negative 0.271. And then the other one, I mean, this is getting worse and worse by the second, but negative 0.0246. That one was right on the screen in front of me. I have no excuse. All right, so as the diagram goes, that's really where we're at. What I can do now, get rid of that, is I can tap in for my min, the actual computation. So if I didn't actually need to report the z-score on paper, quote unquote paper, I could just type it in for z-min and for z-max, the actual computation. And it'll automatically populate those values into my normal distribution formula. You can see on the graph that little purple shading. It's the little tiniest of slivers there. All right, so we're looking at a z-score probability. Oops. We had x values that were between 150 and 180, but that translated, and I'll actually write that 150. That's not a 150. Jeez Louise. This translates to the probability that z is between negative 0.271, which gives us a probability of about 0.0970 if we go in 3 significant. All right, so pretty nice solution, but there's always an easier way. All right, and so you can see, and the easier way is based off of what you see actually right here, normal dist 0, 1. Well, that assumes the mean and standard deviation are 0 and 1. Well, what if I go to functions, normal distributions, and I make my mean and standard deviation 183 and 121.8, as they told us in the problem. Then we could find the cumulative probabilities between 150 and 180, and it'll give it to us all in one shot. All right. The only thing you just need to be prepared for, and you know, it's kind of my way of dropping a hint here, like you're going to have to give the z-scores anyway. All right. So when I ask you a question on the test, it isn't, I promise you, it isn't going to be just a simple matter of saying, what's the probability? You know, final answer, give it to me. It's more like, what's the z-score for the low bound? What's the z-score for the high bound? And then what does that translate to? All right. So that, if you might remember from the last test, that there was a question like that for when it came to binomial probability. All right. So number 2, using the given information in number 1, example 1, find the weight separating the top 25% from the bottom 75%. So it's the 75th percentile. That's what that's talking about. Well, fortunately, we already did some of that work. It would be the same exact process to determine the z-score, but then what we need to do is go the other way and figure out the x values that correspond for that. So I have a third little drop down here that says to solve for x, you need mu and sigma using z determined in the previous folder. All right, so in this folder here, if we set that up to 0.75, it keeps moving on me. All right, there we go. So I set that back up to what it ought to be, you know. So that's in the second folder. Tell the calculator what sigma is. You know, if you can get there with a slider, by all means, but it's a decimal value, so it might be a little tricky. You see, I got it going up to 1,000 here, so you're not going to get the decimal value. So just type it in. With the mean of 183, that I could probably scroll to with enough patience. Well, actually I can't because it's going by tens. So 183, just type that bad boy in. And it'll spit out the value. And let me just tell you theoretically what this is actually doing for us. All right, so we have z-score formula with a known z, but an unknown x. So you can actually solve for x if you want by hand using algebra if you like that. All right. Or you can use this where I did the algebra for you. That's where this x equals z times sigma plus mu is. I did all that for you. So it's set up to solve for x, and x would be about 265.153 pounds. All right, the other question was calling for a probability. This one was calling for an x value, which is in the units of pounds, so we would want to make sure we have that information there.